Hello everyone. Today the N1 group will discuss the concept of RISC and CISC architecture. Starting off with RISC, which stands for Reduced Instruction Set Computer. In RISC architecture, the instruction set of the computer is simplified to reduce the execution time. RISC has a small set of instructions which generally include register to register operations. Thus, data is stored in processor registers for computations and results of the computations are transferred to the memory using store instructions. All operations are performed within the registers of the CPU. In RISC, all instructions have simpler register addressing and hence use less number of addressing modes. RISC uses relatively a simple instruction format and is easy to decode. Here, the instruction length can be fixed and aligned on word boundaries. The RISC processors can execute one instruction per clock cycle. This is done using pipelining, which involves overlapping the fetch, decode, and execute phases of two or three instructions. A RISC takes relatively a large number of registers in the processor unit. It takes less time to execute its program when compared to CISC. Now, Palash will lead you on what is CISC architecture.
CISC Complex Instruction Set Computer MPUs Complex instructions, hence complex instruction decoding. Instructions are larger than one word size. Instructions may take more than one clock cycle for execution. Less number of general purpose registers as operation is performed in memory itself. Complex addressing modes. More data types required. More emphasis on hardware. Difference between RISC and CISC processor. In CISC, the original microprocessor is ISA. Instructions can take several clock cycles. Hardware-centric design. The ISA does as much as possible using hardware circuitry. More efficient reuse of RAM than RISC. Complex and variable length instructions may support microcode, microprogramming where instructions are treated like small programs. Large number of instructions, compound addressing modes, whereas in RISC, redesigned ISA that emerged in early 1980s, single cycle instructions, software centric design, high level compilers take on most of the burden of coding many software steps from the programmer. Heavy use of RAM can cause bottlenecks if RAM is limited. Simple standardized instructions, only one layer of instructions, small number of fixed length instructions. Now Avishkar will proceed further.
So as we see in screen, both the superscalar and ordinary scalar diagram. Firstly, I explain about ordinary scalar organization. This organization also known as the line organization and it is act on single piece of data at a time. In this organization, there is a single pipeline functional unit exist. That is first one is integer operation and second one is floating point operations. As we see in diagram, pipelined integer functional unit is interconnected with the integer register file and pipelined floating point functional unit is interconnected with the floating point register file. And after this, integer register file and floating point register file interconnected with main memory. So from this we understood that both the integer unit and floating point unit is a single pipelined functional unit. In other hand, there is a superscalar organization. Superscalar organization having ability to execute instructions in different pipelines and it is independently and concurrently because of different pipelines. That's why CPU manages the multiple instruction pipeline to execute several instructions. As we see in diagram, pipelined integer functional unit interconnected with the integer register file and pipelined floating point functional unit interconnected with the floating point register file. After this connection, integer file and floating point file connected with the main memory. So here multiple pipelined units are there. Hence it is possible to execute instructions in different pipelines. So scalar organization is single pipelined and superscalar organization is multiple pipelined. So this is the comparison of superscalar and ordinary scalar organization. Now we will discuss about comparison of superscalar and super pipelined approaches. As we see in diagram, first stage is superscalar, second is super pipelined, and last one is a simple four stages pipelined. Superscalar machines can issue several instructions per cycle, and super pipelined machines can issue only one instruction per cycle required for any operations. These techniques exploits instruction level parallelism, which is often limited in many applications. So this is a comparison of superscalar and super pipeline approaches. Now Rupali will continue further.
Difference between superscalar and super pipeline processors. Superscalar rely on spatial parallelism. Super pipeline rely on temporal parallelism. Superscalar multiple operations running on separate hardware concurrently. Super pipeline overlapping multiple operations on a common hardware. Superscalar achieved by duplicating hardware resources such as execution units and register ports. Superpipeline achieved through more deeply pipelined execution units with faster clock cycles. Superscalar requires more transistors. Superpipeline requires faster transistors.